In this video, we're going to cover the graphing of trigonometric functions. We're going to move from the basic functions as we get to progress and look at different forms of functions. So in this video specifically, we're going to cover on how to sketch a sine graph. Okay. So for us to be able to sketch graphs, we need to understand the basic sine function. So pay attention to the basic sine function. Okay, so on our graph, we expect that that's a 0 there. Okay, I'm going to use radians, of course. So we have pi over 2 as a 90 there in degrees. Pi, 3 pi over 2. And finally, we have 2 pi. Okay, so a basic sine function, y is equal to sine of x. Actually, when you get to sketch it, when you try to plug in these values, sine pi over 2, which is sine 90 degrees, is going to give you a 1. Okay. So basically, you have a point there. Sine pi is 0. Sine 3 pi over 2 is going to give you a negative 1. Then sine 2 pi is going to give you what? It's going to give you a 0. So basically, this is the way the graph moves. So when you look at this graph, you need to understand some of the basic things about the graph. Okay, so it has taken like from this point to that point. That's when it has made a complete what? Cycle. So this is what we call the period. Okay. Then the highest in terms of how high it's going in the y-axis, this is what we call the amplitude. Okay. So like I mentioned, this is a basic function. So we need to understand a more complex form of a function. Okay. So now, before I get to move on to a different part, let's try to study a function where we have a different amplitude. So when I put a number there, that tells you what is the amplitude. And how does it affect the graph? Knowing this is our basic graph, as we get to sketch other graphs, we should try to understand how different it is from the original one, or how is something new being introduced, how is it going to affect the graph. So when you put a 4 there, how is it going to affect? It's going to affect the amplitude. Okay, so in short, the graph will go up to 4 there. Okay, notice that it has not affected anything else other than how high the graph is going in the y-axis. Okay, so that would be a 4. This would be a negative 4. Okay, so that is how the amplitude affects the graph. Okay, so knowing that, now that we've understood how it affects the graph, let's try to study the different properties that can also affect the graph. Okay. Let's use this. Okay, so we've understood the basic. We've seen the basic function. Okay, so you need to know that when you have the full form of a function in the form y is equal to a sine bx plus c in brackets plus d. So I would advise you to rewrite that form. Okay. Factorize what's in the brackets. So if you have a b there, you have x plus c over b plus d. This is what we call the amplitude. It's going to affect how high the graph is going to go in the y-axis. This is b, which is going to help us determine what? The period. So the period denoted by letter capital T is going to be determined by dividing 2 pi with the modulus of b. So for example, in a basic sine graph, y is equal to sine of x, we've seen that in such a case, the coefficient of x is actually 1. So that explains why the period is 2 pi. Okay. So now, let's say now we add sine. Okay. We add y is equal to sine 2x. How different can we sketch it? Okay, remember I've already told you the basic. This is the way the basic one is moving. Okay. So that is your 1 as your amplitude. This is your -1. Okay. And that is as far as 2 pi, because that's a period. So if you begin to divide the pi into 4 equal parts, this is pi, this is pi over 2, and that is 3 pi over 2. Okay. So when you look at this one, using this formula, it's going to be 2 pi divided by 2, which is going to give us pi. Meaning that this full graph is supposed to be complete within what? Within pi. So what do? When you begin to sketch it, you expect it to come out this way. Draw a full graph just as you would normally would. Then the last part there is supposed to be pi. Then divide into 4 equal parts. So first of all, divide by 2, which is going to give you pi over 2 there. Divide pi over 2 by 2, it's going to give you pi over 4. Then add, so it's like, this is like pi over 4 plus pi over 4 pi over 2. So you add another pi over 4 to pi over 2. So if you add pi over 2 plus pi over 4, because remember, if you divide pi into 4 equal parts, it will be 1 over 4, 1 over 4, 1 over 4, 1 over 4. So which is going to be 3/4. Okay. So I bet this is making sense. So this is y is equal to sine 2x. Y is equal to sine x. So from this point, we've now understood how the amplitude affects a graph. Then we've now looked at how the period also affects a graph. Okay. Let's try to move a bit. So we've talked about the period already. What else affects a graph? Okay, so that part is what we call the phase shift. Okay, so let's say maybe if it's pi over 2, if it's positive pi over 2, and let's say it's y is equal to sine x. For example, sine x plus pi over 2, like this. How can we sketch this one? How is it going to be different from the basic one? So like I've mentioned, always start with the basic one and see the effect it's going to cause. Okay, so this is the way the basic one is going to be. Basic one. So of course, as you sketch, identify first of all the period. The period is a very important thing because that's what's going to be at the end there. So in this case, the period is still what? It's still 2 pi. So I have 2 pi there. So this is pi. If you divide pi into 2, you have pi over 2. Then now that would be 3 pi over 2. Okay. So this is actually the function y is equal to sine of x. So now, how is the phase shift going to affect the graph? So it is very important for you guys to understand that whenever it is positive, it's supposed to move to the left hand side, and when it's negative, so like when it's positive there, it's like this. So when you equate it to 0, you're going to find that the phase shift is going to be negative pi over 2. So it's going to move to the left hand side. So this point will move to this side by negative pi over 2. Okay, so I'll draw it. So I'll start with this point, the point that is at comma 0, comma 0 there. So if it moves to the left by pi over 2, it's going to be from 0 to negative pi over 2. So this point is at that point, so we've moved it. Then this other point, maximum point there, is at pi over 2. So pi over 2, again, we subtract pi over 2, it's going to move to 0. So remember, it's on top there. This one, pi minus pi over 2 is going to move to pi over 2. So it will move at 2. So this is negative pi over 2. This is 0, and this is pi over 2. Then this other one at 3 pi over 2. If you get 3 pi over 2, again, you subtract pi over 2. You are going to have 2 pi, 3, that is 2 pi over 2, which is going to give you pi. So it will move to pi, which was at this point down there. So it will move to pi. So it will move to pi. Then the one at 2 pi subtract pi over 2. So it will move to 3 pi over 2. Okay. So the point was there, so it will move to be there. So as you get to draw this graph, this is the way it's going to be. Okay. So this is the way, that's the way a phase shift affects a graph. Okay. So even if I was to add a different amplitude there, if for example I put a 4, it will still be, so that point, the maximum point would be 4, then the minimum point will be negative 4. Okay, so just looking at this part, we already have the amplitude, we already have the phase shift, and we've already talked about the period. Okay, so now let's say I add something there. Maybe I say plus 2. How different is it? So that is what you call the vertical shift, which is the D there. So the vertical shift affects the y-axis, just as you are told vertical. Vertical, so it affects the y part. So it's positive, meaning that the graph is supposed to move up. Each point is going to move up by pi over 2. So the one that is at 4 there plus 2, it will move to 6. So it will move to 6. Then this one, which is at 0, is going to move to 2. Somewhere there. Which other point? But this point, which is at 0, will also move to 2. This point at negative 4 plus 2 is going to move to somewhere negative 2. To move a bit up. Then the one at 0 is also going to move up by 2. So basically, after the vertical shift, that's how the graph moves. So you've seen that basically it's like this line has shifted to that point. Okay. So I believe we've already covered the effects of all these, the amplitude, the phase shift, and the vertical shift. Let me just try to talk about the negative sign function. Okay, so how is it different? When you talk about negative function. So remember, we've talked about this basic function. We've said that this is how it's going to be. So what is the coefficient of x? It's 1. So our period is the first thing to determine. So our period is 2 pi over b. In this case it's 1, so it's 2 pi. So what's the first thing to do? You put 2 pi there at the end. It doesn't mean that the graph is going to end there. No, it can continue. So this graph can continue again. So we add another 2 pi to be 4 pi. but you just need to know that you're supposed to make a complete revolution after 2 pi. Okay, just like that. So look at the amplitude. If it's 4, it's supposed to be 4. If it's 1, in this case it's just 1, -1. So this is the sine x. If I say 2x, you've seen that it's actually supposed to make a full complete revolution just within this period, which is going to be, of course, the amplitude is supposed to be the same. So this is the y is equal to sine 2x. Okay, so it has made 2 complete revolutions within 2 pi. That's how it's different. Now, that's not my main focus. I want to talk about the negative sine function. So now, let's say I say y, yeah, okay, let me use this one. Let's say I say y is equal to negative sine of x, negative sine x. How different is it going to be? So the only difference is that it's like there's going to be a mirror there. Okay. So this point will be the same. So remember, if you had to come up with a table of values, this point is 0. So what is 2 pi? If you divide 2 pi by 2, you have a pi there. Divide pi by 2, you have pi over 2. Add pi over 2 to pi, it will be 3 pi over what? 2. Okay. So if you are to come up with a table of values, x, you have 0, 0. You have pi over 2. Then you have pi over 2, it's 1 there. From there you have pi, 0, just like that. Okay. So the only difference is going to be to the y values. The negative is going to be affecting the y values. So the ones that are positive are going to become negative. So it's like you multiply them by the negative. So this one will become -1. And the point where we have 3 pi over 2, which is actually in this case -1, it will become positive. So therefore, the way the negative sign graph is going to come out is it's going to be this way. This is always going to move. So this point will be maintained. Then that one will be reflected. It will be somewhere here. This one will be maintained. This one will be reflected. So this is where it's going to move. Okay. So that's the way it moves. So let me just try to remove the basic sign so that we're able to see. Or let me just try to show it down. So therefore, y is equal to negative sine x. Okay, let me try to add something to make it a bit, okay, just like that. It's going to be like this. Okay, so look at the period. If I put 2x there, determine the period. Period is going to be 2 pi over 2, which is going to give us what? Let me put a 4 there, which is going to be pi. So at the end there we need to have pi. Divide pi into 2, we have pi over 2 there. Pi over 2 divided by 2, you have pi over 4 there. Pi over 4 plus pi over 2, you have 3/4 there, 3 pi over 4. Okay. So now look at the period, or look at the amplitude, which is a 4. So at the highest point there's supposed to be 4. The lowest point is supposed to be -4. So all the same, if we are to put +2 there, this point is supposed to move up by 2. This one is supposed to move up by 2. If it's negative, it's supposed to go down by -2. Okay, so this is actually the way, the general concept about sketching sine graphs. So I just hope this video gave you an insight on how to go about sketching sine graph functions. The same concept applies to cosine functions, except you need to know that as you talk about sine functions, which of course are going to be covered in another video, okay, just in case you want to cover them now before the video is shared. So the basic, if you just know the basic cosine function, then you're good to go. So the basic cosine function, cos x, actually moves like this. Instead of starting from 0, it will start from the amplitude. Okay, so in this case the amplitude is 1, so it will start from there. Okay, so in this case the period is actually 2 pi over 1, so which is 2 pi. So therefore the last point there is going to be 2 pi. So if you look at cosine 2 pi, which is equal to cosine 360, it's -1. And when you look at cosine 0 there, it's also equal to -1. That's why cosine graph starts from top there. Actually, because 0 is 1, not positive, not -1. Yeah. So you have this point, which is going to be, first of all, the 2 pi divided into half, which is going to be pi. So cosine pi, or cosine 180, is going to give you -1. So this point is going to be actually pi over 2. Then this is going to be 3 pi over 2. So just like we've discussed, the way the amplitude affects it, if you have a 4 there, it will be 4 there. If you have we've already talked about the period, so the phase shift as well, it can be moved to the left, to the right, depending on the sign. Then the vertical shift can also move it up and down. So I just hope this has helped you understand how to sketch or graph trigonometric functions. In the next video, I'll cover tangential functions and some basics under cosine functions as well. So I just hope you enjoyed this video. Comment and like and subscribe to encourage me to make more videos like this. Thank you very much for watching.